In this video, we're going to practice identifying a function given its graph, and we're going to apply our concepts of transformations, primarily here translations, to create these equations. So the first part of this is to identify the type of function represented. Is it a constant? Is it an identity? Is it an absolute value? Or is it a quadratic function based off visually looking at the graph? And then the second part is to write the equation. So I'm going to look at both 1 and 2 just for identifying first. I see here that this graph is V-shaped, so that's telling me I am dealing with an absolute value function. And if I look at number 2, I see that this is U-shaped. It's parabolic, which means I am dealing with a quadratic function. And this is helpful because it's going to allow me to look at our transformations, our translations that occur from one to the other. So if I were to pull up that form that I told you, formula that I told you to write down for absolute value quadratics, I said the way to go about doing this is to identify your A, your H, and your K first to determine how to write the equation. And so we're going to do that. So I have absolute value here on the left, I have quadratics here on the right. Telling you we're going to be working with on these examples primarily transformations. So we're not going to be focusing too much on our A value here. We're just going to be focusing on identifying our H and our K. So your H is your horizontal. So the original absolute value function, if I were to graph it, I'm going to use a dashed line so it's easier to see. 0, 0 is the vertex, absolute value is 1 is 1, absolute value of negative 1 is 1, absolute value of negative 2 is 2, absolute value of 2 is 2, and that pattern goes on and on and on. And again, I'm going to use a dashed line. So here is the original function. Now this is a translation from that function. I had to figure out what type of translation it is. If I take a look, it looks like I went to the left 3 units. And since I'm going left 3 units, then that means my H value is negative 3. There is no vertical change, it's still on the same, so then my K value is 0. So I see here right now, we're not worrying about A, but I know H is negative 3. I know K is 0. And so when I plug these into my absolute value equation, I get Y equals, we're not worrying about A, so we just have the absolute value. It's X minus, and our H value, we're saying is negative 3. So I'm subtracting a negative 3. And then I have my absolute value plus K, and K is 0. Now we're going to simplify this to get our final answer. Subtracting a negative is adding, so I have Y equals the absolute value of X plus 3. And we don't ever show plus 0. So then this is the equation of the absolute value function. A horizontal translation occurred to the left 3 units. H is negative 3. When you subtract a negative, it becomes a plus sign. Let's try and do the same thing over here. We're going to sketch the original, of our quadratics. So 0, 0, 1, 1, 2 squared is 4. Negative 1 squared is 1, negative 2 squared is 4. And we're going to use a curved dashed line to represent this function. And we have to ask ourselves, what type of change occurred here? So if I look at my vertex, it stayed on the same Y, so my K is 0, but it went to the right 2 units. That means H is positive 2. So I have an H value of 2, a horizontal change of 2 units right. I have a K value, it did not go up or down, of 0. So the same idea, let's plug these into our quadratic. Y equals, we're not worrying about A, so parentheses, X minus what my H value is, which was 2. And then I have parentheses squared plus K, and K is 0. So let's simplify this now. We can't really simplify X minus 2 squared, so I have Y equals X minus 2 squared. But we don't show a plus 0, so then this is our equation of our transformation. So those are our absolute value quadratics translations, going from a graph, identifying the function, and writing the form of the equation there. If we look at 3 and 4, if we want to identify these, I see on 3 and 4 that we have, for 3, a horizontal line. And so this is going to be a constant function. I see on number 4 we have a linear, so this is going to be our identity function. To create these equations, we're not going to focus too much on the translations that occur. We're going to focus primarily on just looking at the graph. This is a horizontal line that goes through a y value of 2. So that means my y is always going to be equal to 2. So y equals 2 is the equation. For this identity function, we can kind of think of slope-intercept form to help us out because it is linear. You know, we have a slope of up 1, right 1, up 1, right 1. So our slope is 1. Our y-intercept is 0. So, you know, we have y equals 1x plus 0, which when we simplify it just gives us y equals x. And so this video is kind of introducing the idea of identifying a, h, and k with quadratics and absolute values and writing equations of constants and identity functions. We're going to dive deeper into each type of transformation in the rest of the videos. We're going to examine translations by themselves, reflections by themselves, and dilations by themselves. And then we're going to dive into a problem that involves multiple concepts and identifying the equation and graphing from there. So please review this chart to make sure you understand how each value affects the shape before you move on to the next lesson.